So what I'm going to do is I'm going to show that the Pythagorean theorem is indeed true and how we can do that. I'm going to do it in a more fun way, a visual way. So the first thing I'm going to do is I'm going to make a triangle, which Pythagorean theorem revolves around right triangles, right? And I'm going to come like that, and I'm going to just copy, make 4 copies of the exact same triangle. And we know that they're all the same size because I literally just copied and pasted them. And I'm just going to arrange them in a certain way. And I don't have to get it perfect, but I want to get it looking pretty nice. And this is kind of where we start. Move it. There we go. Good enough. We'll be able to get the idea. And what I'm going to say is these are all right triangles. I'm going to say that, I don't know, this side is A, this leg is B, and then the hypotenuse across from the right triangle is C, right? And that's going to be the same all the way around, right? This side is going to be A, the long side is going to be A, the small side is going to be B, small side is B, long side is A, short side is B, long side is A, right? We can go all the way around, and these are all C all the way around. And I want us to note that we kind of found 2 squares. The first square we see is the one that we kind of made in the middle here. And I want us to note that it doesn't just look like a square. We know it's a square because all the side lengths are the same, right? This is C, 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 and C. All the side lengths are C, so that means we have a square, right? When all the side lengths are the same. And now I want us to take note of the area of the square. So the area of the square is just going to be side length times side length, right? If we had a 4 by 4 square, the area would be 4 times 4 is 16. In this case, it's going to be C times C, which is C squared, right? And I might just make a rough square so that we can remember this. I'll try and make it roughly the same size. That's pretty good. Doesn't need to be exact, but just so we have it for future. Okay. So we said this square was C squared. Okay, and now I want us to remember this triangle. I'm gonna get rid of all the stuff in here. Maybe I'm just gonna write C squared here. Maybe this will help us later. And I'm gonna highlight all of this. And group it and copy it so I can paste it later. But now I want to ungroup them. Okay. So we found this middle thing to be C squared. And I also want us to notice that we have another square on the outside, right? And again, we know this is a square. This square is A plus B units long, right? A plus B, A plus B, A plus B, A plus B, all the way around, right? And so we know that the area of the big square is A plus B squared, right? A plus B times A plus B is A plus B squared. And that's just something we're going to keep in mind. So I'm going to get rid of this. And I'm going to use my same 4 triangles, and I'm just going to rearrange them a little bit. Point this one down and stack it there. Point this one up, stack it there. And we're going to throw this one down right here. Same 4 triangles. Right. And now they're not perfectly placed, but it's good enough. We should notice that we have 2 different squares that kind of conform here. We have this one. This one here. And I'm going to do my best to outline this one or keep this one straight, and this one here. All right, good enough. All right, and so what I want us to notice here, remember our long side was A and our short side was B. And so what are these squares? Well, let's keep in mind that the short side was B. Here's the short side of this one. And the long side we said was A. Here's the long side here. Well, isn't this square A squared? Because this is the long side A, this is the long side A, so we know it's a square. And again, the area, just like this one is C squared, this one is A squared. And then this one, right? Isn't this small side here B, and this small side here is B? B times B gets us B squared for the square, the area of the square. And so this kind of tells us that A squared plus B squared, oops, maybe I'll do the plus in a plus B squared equals C squared. This tells us the Pythagorean theorem, but why? So I think this is kind of fun here. Why does this tell us that A squared plus B squared equals C squared? Well, let's take a look at the big rectangle, or the big square again. All right, so the big square, this side length is A, right? It's the same side length as up here. So this side length is A, and this side length is B. It's the same side length there. So again, our big square is A plus B by A plus B, right? Or A plus B squared. So if we have the same big square, right? We have the same big square both times. Maybe this is where bringing in this old triangle, right? The big square is the same in both times. Maybe I'll bring it down here a little more. Both times the big square was A plus B by A plus B, right? A plus B times A plus B. And in both squares we had the same exact 4 triangles. 1, 2, 1, 2, 3, 4. And it's the same exact triangles here. 1, 2, 3, 4. Right? And so that means the space that's left after you take away those triangles has to be the same, right? Because the area of those 4 triangles are going to be the same in both. And since both of the big squares have the same area, that once you take away the area from the 4 triangles, what's left has to be the same. And what was left in this one? C squared. And what's left in this one? A squared plus B squared. Right? And so that is a fun little visual proof of Pythagorean theorem, A squared plus B squared equals C squared.